All right, thanks everyone. I know this is the end of the second half of HTTG, but thanks for bearing with us. So my talk is about transitioning makerspaces into seeing spaces. And kind of the way I made it attractive to the Meetup post is the second sentence is, can we actually start seeing and understanding what our hardware is really doing? And we'll go into that. This is a hardware. You see hardware down here, but a lot of the concepts I'm going to be talking about are more conceptual exploration. So bear with some of the slides. So quickly, who am I? Jonathan Beri, either Beri Kicks, like the cereal, on most GitHub and Twitter, or Jonathan Beri elsewhere. My day job, I'm a product manager. I work at Nest on our developer program. So I do cloud stuff, I do embedded stuff, and I do low-power mesh networking stuff. This is actually my opinion, not my employer. I consider myself a maker, like many of you. I co-authored a book about building robots with JavaScript. So that's one of my claims to fame.
What was the name?
The name of the book? Make, JavaScript Robotics.
Who's the other author?
There's about a dozen other authors.
Oh, okay.
So it's each chapter is a different project. It's pretty cool. You should check it out. Put together a quick agenda of the things that as I was thinking about my talk, starting with the inspiration. Why did I even propose a talk, and what got me trying to make seeing spaces? My little experiment that's ongoing, and a snapshot of what I've been doing, and moving into what I learned so far from trying to build a seeing space, and what I'm going to do next, maybe a future Hackaday talk. So to start with the inspiration, if you look at this screenshot here, this is a Mission Control Center in NASA. This is the ultimate productivity tool, right? Imagine if you had your MacBook was this big, right? Your IDE had this many screens, and you had the kinds of UIs and controls that would allow you to build whatever you need to build in such an immersive way, such a useful way, with data that's responsive, very specific, actionable, and controls that are not command line interfaces or drag and drop editors. And this type of space inspired a very smart guy named Brett Victor. Anybody know who Brett Victor is? All right, cool. I think his official title is an interaction designer. I classify him as a futurist, if you watch any of his other talks. But he's also, comes up with these crazy new innovative ways to help people make stuff. He also happens to have a master's in electrical engineering, which makes his perspective quite unique. And he did a talk a few years ago about this concept called seeing spaces. And when I saw that talk, I was immediately inspired. I wanted this thing to exist. And when I watched it for the first time, I planted the seed in my head, how can I make this, right? And, he started looking at traditional maker spaces. And if you look at a traditional maker space, it's a room full of tools that help you assemble stuff. Cut stuff, glue stuff, slice stuff. And it's a collaborative space, which is awesome, usually with pooled resources. But it's sort of limiting in the level of complexity of the things you can build. Because today's modern projects are super complex, right? They're not just chairs or fans, right? They're systems with subsystems and embedded systems and radios. This is actually one of my favorite Hackaday projects from Andreas. He builds fully 3D printable robot arms. Super awesome, and all his sources are online there. But if you look at this, right, and you just have this robot arm plopped on your desk, and it starts doing something, how do you know what it's doing? How do you know it's doing the right thing? How do you look inside that product and say, well, this robot arm is supposed to be moving in this pattern, right? We have some ways of diagnosing and understanding these complex systems, but if you just had that in your hand, how would you do it? Because if you have something like this robot who looks a little bit drunk, we have the tools of the trade, right? Scopes and meters and analyzers. But all they can do is look to a certain level of what's going on, what the engineer decided to pull out on a debug port, or what outputs a particular motor has. But for example, that same motor, you have no idea if the shaft is spinning at a small angle. You don't know if there's friction in one bearing. You don't know what's causing the friction to even happen. You really can't see inside the thing. And without seeing what's inside that thing, you really can't understand what's going on. That makes building new things harder, and getting to that level of super complex, interesting projects even more of a challenge. So that's when Brett proposed this concept of a seeing space. And in this cartoon is how he envisions a seeing space. And just to highlight a few things. It harks back to that mission control center with the big displays, huge amounts of data that's easily viewable. But you notice that there's a bunch of sensors. For example, you have cameras above looking down, trying to figure out what's going on the table below. Maybe some microphones listening for not just audible from humans speaking, but what the machine maybe is doing. Depth sensors, touch sensors, and of course you also have those maker tools in the background. That's the general idea of this seeing space. And if you want to break down, he proposed 3 key pieces to building a seeing space. Having the ability to see inside what you're building, having the ability to see across time, which gets really interesting, and then seeing across possibilities, which is kind of that magical, wow, how'd you think through all these scenarios? And seeing inside is something as simple as just collecting data and displaying data, but what I learned in just a few weeks of experimenting with trying to do that, that's actually really, really hard, even to get at the basic level of collecting data. So going one step deeper, trying to figure out what's the complexities involved in some of this. So he uses this example of a little rover, simple 2-wheel drive thing, embedded system, and a sensor. Well, in this space, it's collecting all sorts of data. Some things that might be obvious, like the encoding in the wheel. Maybe that's a positional sensor. Maybe the output of the sonar on the front. In the background, it's way more stuff. To actually understand what it's doing, you have to know everything about that device. So you have the schematic back here, maybe a SPICE simulator going on, and you have the registers and debuggers built right in that maybe you didn't actually write yourself. But then you have the cameras and the sound. Trying to understand where that thing is in space, even though that is a thing that the system knows about, has to be inferred somehow, and that alone is just a super complex problem. And then taking that data, displaying it in all sorts of useful ways that you can act on, not just writing print line statements and doing JTAG debugging, is the next level of thinking. Just amazing. Now, going from seeing inside and seeing across time, that's when you start getting a lot of utility of collecting all this data. So we as humans, we can only look at snapshots of data in time, bright lights and sounds. But it's really hard for us to perceive things over time. And when we're able to view things over time, for example, weather, right? If it's really 72 degrees, you don't know what that means. But if you see a series of warm, it's going to be a warm week. So if you can take all those data inputs and see that over time and compare different historical trends with your system in the seeing space, it makes it really easy for humans to see, well, oh yeah, there was a for loop right there that took a little bit of time. That's why the thing didn't move fast. It starts becoming really powerful if you can look at that historic context. And then you can actually start seeing effects of changes over time. So maybe you change something in an experiment that you may have not noticed. Maybe the table changed. There was a piece of paper that caused the robot to slip, but it actually had a better performance result. So you can actually figure out where those changes are occurring and help you improve your system. I don't know about you today, but the code I write today has nothing even comparable to historical logging. But here's where it gets kind of magical, and I kind of get excited. This is seeing across possibilities. So we have all these sensors. It's reading everything about the system. We can graph it over time. But what if, just by doing a few sample runs, the system has enough data to project all possible scenarios of this little robot? So you don't even have to run the experiments. The system can run it for you. But he calls this concept of automatic experimentation, which is sort of like the golden Medina of this whole system. If anybody does mobile development here or game development, you know about automated testing, tap testing. That's previous job saved us boatloads of testing. This is the next level, right? But when I saw this, I felt this is kind of achievable, right? Maybe in years with other people's research, maybe with a lot more money than I have access to, but the individual pieces make sense to me. And we see a little bit of this today in our tooling. So I got excited. I wanted to see this exist. So I thought I'd try an experiment, and it's honestly going on. And I've only touched the bare minimum of that surface, but I wanted to try to see what I could do from that vision and build a seeing space, actually in my own home, in my little maker corner. And what really sparked the idea to begin on this journey is our favorite Wi-Fi chip. It's the ESP. Because if you have all these devices, even if they're just external sensors, and you want to be communicating tons of data, you need lots and lots of wireless sensors. Be able to log that data and connect to the cloud. $3 a chip, okay, it's not as small as it needs to be. It's not as cheap as it needs to be. But it's that beginning, broaching that point where you can actually start having a bunch of devices connected. So I figured I can just try tackling the data collection part and data displaying. Take some tools, add some connectivity, and simulate sort of that cool space center. So I tried to deliver 3 things. And honestly, I started this actual part of it just 3 weeks ago. So not a lot of investment, but I've been thinking about this for probably a year now. I said, okay, in 3 weeks for this talk, I can do 3 key things. I can build wireless tools. I can build a real-time data logging system and do data visualization to some degree, right? And that just translated to a bunch of ESPs on tools that I had around. MQTT, if you're not familiar with internet protocols for IoT, this is one of the more popular ones, and just an HTML dashboard, right? Simple, but I've done stuff like this in my day job pretty regularly. So for those who are watching this on film, I have a bunch of the tools that I built on the floor here, but I took things I had around the home and things that it was easy for me to acquire. I got a bunch of ESPs. They were tiny. I had calipers, which have serial output. I found a serial DMM, pretty cheap on Amazon. And I also made a wireless serial bridge, right? So to sort of see inside a microcontroller. Put some MQTT software on top of the chips, as well as MQTT server, which I have some horror stories around that. But then I was able to log wirelessly from all these tools. So I poked around things in my house, and now I have wireless calipers. So my 3D prints, I can just go around, start squeezing things. I can see spikes, and I can even pause it, right? So makes it a little bit easier. And my DMM, go to a little robot I have around, figure out how much battery the juice has the battery left, and I don't have to keep on checking at it. I can actually keep it attached to the robot, and I even have a wireless serial bridge, so I can sort of send serial debugging without having to be plugged into the side of the computer. This is actually pretty useful, even alone without trying to build this awesome seeing space. So I felt pretty good. I felt like I had something pretty useful. But to be honest, I really did this to learn just the beginning of how I can approach this problem, right? So I learned a ton of lessons, some of them that I want to share with you right now. Sort of 4 key things. 1, there is no Seeing Spaces OS. What that means, I'll go through in a second. The UX of the hardware themselves needs to be rethought. How would you build a Seeing Space hardware to build new types of products? The third one is really a lot of these challenges is the same challenges we see today in IoT. So it's really IoT in disguise, and this is an area that I think a lot about. And the hard parts are going to be really, really hard. And I haven't even got to the hard parts yet, but I know they're going to be hard. Just think about the easy parts. So the Seeing Space OS. What do I mean by that? The sort of the software layer, the sort of lower infrastructure pieces were really complicated. Even as somebody who knows how to write embedded software, how to build a back end, and how to and even know about wireless, right? So for example, I tried to build just a super simple MQTT server that could run here during this talk without having to join the Wi-Fi network and reflash new credentials to all the little ESPs, just in case that was an issue. Well, There was not a really good software that can run on my laptop or even on ESPs themselves. I tried to do that. That took a lot of gray hairs. And then the cloud infrastructure to try to just run an MQTT server. They're pretty flaky. They're not reliable. They're really hard to set up. But not only that, they have no application-specific knowledge in them. They don't know anything about seeing spaces. This is an idea that Brett made up, and I'm trying to create an application layer on top of them. And I'm spending time trying to come up with a topology for what a device is versus a caliper versus a multimeter, right? OK, but that's reasonable. On the embedded side, embedded platforms themselves have no idea of being wireless connected tools. There's no drivers, for example, for a caliper in any system that I've seen. I used Arduino for some of the code. Some of it was bare metal. And each one was bespoke. And I had to come up with how to do that for the particular piece of hardware. A lot of the hardware that I had around the house had no serial output, so I couldn't even make them wireless. I would have to break them some way. The third piece is, hardware is actually kind of dumb. And I purposely made dumb terminals. But Brett has this very interesting saying that resonates with me. Traditionally, we think that if a maker's project breaks, it's their fault for not tightening the wires down too snugly. But actually, he blames the wires for not being smart enough to know that they're disconnected, let alone they don't reattach themselves. And so the tools that I had around and the tools that we use to prototype projects or even build production products are kind of dumb, right? They have no sense of awareness. They have no sense of, am I connected to the thing I need to be connected to? We write application code on top of each one to know that, hey, you just had some debug messaging during Bootstrap to say, yeah, this is there. But they have no way of helping us design them to be more intelligent. Okay, I'll get into that in a minute. And the UI, that cool Space Center type of UI, is just really hard. I'm not a UI designer, but I couldn't go on GitHub and find seeing spaces.js, right? And each of those interaction models, they have to be designed and thought through, and they don't exist today. I'm sure some really smart UX group can figure it out, but we don't have them yet. The next about new hardware UX. So I took simple tools that you sort of use visually, and I tried to add connectivity so that I can use them elsewhere. And that turned out, even if the tool had a serial port, to be a really tedious job. I mentioned there was no seeing space driver library, right? But even still, like the multimeter speaks a serial protocol, and the calipers speak a serial protocol. But they're not the same type of serial protocol, and they're clocked differently. And one has a clock I can rely on, one doesn't. And at the end of the day, I'm just trying to dump as much data out as I can, but even getting the data out of that device was really challenging. And that's just for 3 different types of tools. Imagine new tools you create with other tools and get more complex tools, so smarter scopes, for example, that build upon other types of sensors. Those have to be thought of and built out. The next is just adding wireless connectivity to a tool is not immediately useful. It's actually kind of awkward. So I have this multimeter, and I stuck it on 2 pins of my Arduino. And it was great, but I had to hold it there. Or I had to find clips. Or I had to figure a way to mount it on top of the robot to be useful. So that leads me to my last point. The design paradigm of tools have to be reimagined. I need to somehow have all these tools on top of my project, or better yet, inside of my project, right? I've been following along all the developments in FPGA design, right? And there's we were talking earlier today about one of the Xilinx parts that has a ARM core in it and just I/O all around it. What if the I/O all around it was your seeing space tools, and it was in the chip was actually evaluating itself? Maybe it has a logic analyzer right on the chip. Anyway, those kind of things. We're even seeing just something simple today. Wireless multimeters, they don't have screens, and they have different types of connectors on the end, right? They're probes, right? That's a different way of thinking about UX. So, and this is sort of where I spend most of my day job thinking about is IoT, and really these types of problems are just analogous with what we see in IoT, whether it's the home or the enterprise or the factory. So for example, pairing, right? When you get a new device for the home, you have to have an app that puts the credentials. Well, I accidentally reset my router in the middle of one of my experiments, so all my IP ranges got reset, and also the default name of the router and the host name got reset. So I had to go and plug in USB cables into all the little ESPs and reflash them. And that, that's fine for this little experiment. But what happens when you have thousands of these, right? The UX around flashing, integrating, booting up these devices needs to be fluid, like opening up a web page. So that leads me to what happens when you have thousands of these things. If anybody who works in radio technology, they know that when you start having a lot of radios in a room, that alone is a problem. What happens when you have a shared network and you got a lot of packets flying everywhere? Like these thousands of nodes or more nodes are going to create millions of problems, right? We haven't even foreseen how to handle that kind of complexity in such a small space. And the last point about IoT, a lot of end game for a lot of companies is the big data. But typical big data IoT problems is you log a bunch of data, you store it, you run a process over a couple days, a couple months, a couple years, and you get some results. But if you're trying to create a new prototype for a project, you need results immediately. Not only that, the things you're building, these robots, these robotic fish, for example, they've never existed in the world before. So the data models don't exist to represent these in the system in order to find unique events to understand and to notify you about. And I haven't even thought much about the hard parts, but I just know the hard parts are going to be extremely hard. If I'm having my head spin around just about logging from a caliper, things like machine learning, understanding that there's a robot in the room that's this shape and this dimension, it's going at this vector, and that it actually slipped on a piece of paper, and that the motor on the right just heated up a little bit and now it's cooling down. All that stuff has to be processed in unique ways that traditional engineering doesn't cross yet. So I'll be cool, but I don't think I'll be trying that anytime soon. However, in Brett's talk, he says we have a lot of this technology today. We've seen the advances in machine learning. Right? We've seen the AlphaGo and how they are able to process huge amounts of data in really, really complicated ways. So if a company's invested, or there are companies who have access to this technology, can actually drive some of this to fruition. All right. So what's next? I'm speeding along through this because I didn't want to take too much time. So for me, I said this is an experiment, and I'm going to try a few things probably in the next couple of weeks. This is not on Hackaday.io yet, but it'll be on I/O this weekend because I was busy making these slides. I'm actually making more wireless tools. I said they were awkward and hard to use, but I actually found them useful in my normal non-seeing space life. Having a wireless caliper is pretty awesome when you're 3D printing. So is a dial caliper. It's great for bed leveling. I really, really want a couple wireless logic analyzers that I can just leave on my robots and not have to worry about taking it out and putting it onto another system. And there's a couple other interesting things you can do that I have lying around the house. Also on the cloud side, a lot of my background is in web development and building servers. So just build some sort of infrastructure on top of MQTT, perhaps, that makes it really easy for other people to create these types of spaces, maybe even for your own personal work area. That's a lot on the spaces, Seeing Spaces OS. On the hardware side, I'm super keen on FPGAs. I used to play around with FPGAs in college, haven't touched them, and now everybody's playing with them, so I feel like I need to get in the game. But there's actually really cool new companies doing wireless FPGAs. So we have a couple of those at the office, and in this concept of, well, if your chip is not just your chip, but also your inputs to your seeing space, what if you have dynamically capable to change around your wireless connectivity? So people are playing with things like turning it into Bluetooth for pairing, then turning it off and becoming a Wi-Fi for logging. I think it's pretty neat. But also, I just want to play with FPGAs, and I can convince our engineers to let me get at them. And then on the IoT side, this is a little bit of a plug. My company works a lot on 802.15.4, low-power mesh networking stuff. We just open-sourced our protocol, and I'm having a lot of fun playing with it. So I want to see if that's a better solution for building many nodes in a seeing space. All right, and just kind of wrap up this whirlwind talk, I really want to stress that this idea came from Brett Victor. His talk is on his website. It's not just a video. It's a pretty awesome video. But he actually made a cartoon in case you don't have 15 minutes to spare, which I got some of the images from. And it's really neat. And there's other talks there which are pretty mind-blowing about different ways to think about IDEs. I kind of ran through this. I didn't put a lot of details, but open it up for questions if you have questions, any ideas, any thoughts. What's the deal with power constraint and costs? I think it's, we're seeing that stuff go down pretty quickly. For example, just on the power constraints, it's not just getting chips that use less power, but it's exploring different technologies. So 802.15.4, for example, if you, this is me going to work mode. If you have a front door lock, right, and it's got 4 AA batteries, if it had a Wi-Fi chip on it, that would last about 6 months with normal types of polling and sending pin codes back and forth. On a 15.4 radio, you get about 2 to 3 years with the same level of functionality, as long as you can talk to another 15.4 radio. So,
as long as you're not talking Zigbee.
As long as you're not talking, yeah. No, Zigbee's okay too. But it's really about the network layer. The network layer can be more efficient. And the cost, I mean, $3 for a Wi-Fi chip, it was like, what, $10 just a few years ago?
Yeah, I just think the cost of just always polling, always
Yeah. There's a trend line of how much data costs, right? And maybe it's not here today, but consumer storage, which is medium frequency of retrieval, is getting close to free for gigabytes. And you get compressed data, like sensor data can actually be pretty compressed, especially if you start doing compression algorithms across sensor data. They don't change that often. So I don't know. It's definitely expensive. It's definitely hard to do today, but I kind of see where we're going, making it possible one day. Ross? Oh, the question was, have I looked at robot operating system? Yeah, actually, I played around with Ross, talking about the messaging bus. Yep. Yeah, I haven't used it for this context, obviously. I started this 3 weeks ago. But, maybe a question for you is the application for a robotic operating system is really geared towards robots and has concepts around robots. But I use robot demos because I like robots. But what if you're building a plastic sewing machine that uses plastic filament, for example? That may be able to be modeled. I don't know. That's true. That's very true. Yeah. Yeah. No, it's a good idea. I don't know a lot about Ross though. So if you have any recommendations for me or anybody online, that'd be awesome. Send it on a meetup. There's more questions. Yeah.
Well, just one thought I had. Something that might be some low-hanging fruit is integrating in an Amazon Echo.
Okay.
Yep.
Yep.
I think they have some sort of a developer
Yep.
platform. You can write your own skills.
Yep.
And so even just something where I can say like, I don't want to trigger, but like Echo measure the calipers right now.
Yeah.
Like I got it.
Yep.
And then just go and you can take all your measurements of your part in like a couple of seconds, so that you don't have to put the calipers down and write something down or type something in.
Yeah. No, that's an awesome idea.
Yeah.
Yeah. Voice input. That's the future.
Yeah, I saw the Connect, but I didn't see an Echo.
Yeah. This is before the Echo.
Okay.
That was from Brett's cartoon, by the way. Other ideas? Questions?
How much of the FPGAs you're playing with? It seems like it'd be easier to just get like a Bluetooth and ESP.
So the Bluetooth the FPGA that I'm looking at is actually technically on Crowd Supply. It's a Lime Microsystems. It's pretty neat. It's $200, which is like the cheapest. It's like orders of magnitude cheaper than wireless FPGAs in the past. But yeah, that's more to prototype than even at $3 for the ESP, I think that's pretty expensive if you want to get 1,000 of these. But the other important point about being a seeing space and a makerspace is that it's a shared space and communal cost, right? So maybe that won't be so expensive in a few years, especially if it's community driven. Perhaps.
Have you talked to Makerspaces to see what are their thoughts on this?
No, not yet. Not yet. I go to the Noise Bridge every Saturday, but this Saturday. Cool. Well, if anybody wants to collaborate or have ideas, you can reach me on the Twitters, the GitHubs, the Google Pluses. I'll put the project on Hackaday as I build it out, and also the source code for all the ESPs on GitHub. Cool. All right, thank you very much.